Hello everyone. In this video, we're going to talk about sets, its methods, and why sets are used. Set is a commonly used data structure like lists and tuples. Sets don't contain repetitive elements. All the elements in the set are unique. They are used when the order and frequency of elements doesn't matter. Sets are efficient in membership tests. That is, if you want to check if an element is in the set, it takes only a constant time. You cannot access the elements by index, and the order may be different, but it is considered as a good alternative than lists when we want to find the similarity between sets and use membership tests. A set is created by using a set constructor. This creates an empty set. We can fill it with elements by passing a collection such as lists. A set can have an integer, a float, a string. It can have a tuple, but not a list. Tuples don't change as they are hashable, but lists are not hashable. You can also create set using curly braces and separate elements by a comma. But be careful that using an empty curly brace will not create an empty set. It is reserved for dictionary. It will create an empty dictionary instead. So use the set constructor if you want to create an empty set. So now let me create an empty set for now. And working with a new data structure, it's always best to see the list of methods that it can support. So let's print the directory of lists. We can see the add and update methods. These methods are used to fill the set with new data. Add method lets you add a single element to a set. So if I want to add a few even numbers, I can use the add method. Let me try to add 2. So if I save and run it, you can see our set contains 2. That's good. But I want to add multiple elements, and adding one by one isn't good for me. Let's use the update method. This lets you pass multiple elements by passing lists or tuple or another set. Let me pass a list of the even numbers I want. If I run it, I get what I expected, although the order may be different. Sets support the len function. So if I print the len, we can see that the set contains 6 elements. Set also supports min, max function, and sum function. So now that we have added some data, let's look at the methods used to delete some data. We can see 2 methods, remove and discard. Let's see what it does. Let me delete the number 2. So if I run it, I can see 2 is no longer in the set. Now let me try to delete an odd number which is not in the set at all. Let me try to delete 3. Oops, this shows an error as the number we want to remove is not in the list. So this will be a problem if I want to remove an element which I don't know if it is in the set. And this is where the discard method is helpful. This method deletes an element if found. If an element is not found, it simply returns the set without raising an error. So if you want to be notified when delete a non-existing element from the set, you use remove. Else, you can use discard. Now let's talk about few other methods that lets us find the similarity between different sets. Let's talk about the intersection method first. This method returns the common elements present in the sets. So in order to demonstrate this, let's create 2 sets with some easy numbers. Set A contains numbers from 1 to 4, and set B contains numbers from 3 to 6. If I want the intersection between A and B, I use any set followed by the method name and pass in the other set. So A intersection B. This prints the common elements present in A and B. You can see A contains 3 and 4, and B also contains 3 and 4. So the common elements between them is 3, 4. I can also use more than 2 sets. Let me have a third set, C, that contains few random numbers. If I want to find the intersection of these 3 sets, I just have to add the third set to the method, separated by a comma. The arguments inside the method can also be a list or a tuple. If I change the sets B and C to a list, if I save and run it, this works fine. But note that the method to be called upon should be a set, that is the set A in our case. If we convert A to a list and then run the program, this doesn't work. Intersection is a set method. We should have it as a set, but the arguments that we pass can be a list. If we want to print all the elements present in both A and B, we use the union method. When I run it, we can see all the elements that are in both A and B. But of course, we can see 3 and 4 only one time, as sets contain only unique elements. Now intersection returns the elements that are both in A and B. There is a method called symmetric difference, which returns every elements that are not common in both A and B. We can see that except 3 and 4, all the elements that are common is printed. So till now, we've been working using methods intersection, union, and symmetric difference. It doesn't matter if I used set A first and then pass in B, or used set B first and then pass in A. It works the same. If I use B dot intersection A in the methods we saw, it works the same as A dot intersection B. But few methods like difference and methods with updates on them, the choosing of the sets matter. Now, so let's talk about difference method. Now, if I want to print the elements that are only in A but not in B, I can use the difference method. We use A dot difference and pass in B. Notice that I have used A dot difference of B and not B dot difference of A, because I only want the elements present only in A but not in B. We see that we get the elements 1 and 2, which are in set A. But if I run B dot difference A, we can see that it prints the elements that are in B but not in A. This is different from the previous form where we got the unique elements of A that are not in B. Now there are few methods like difference update, intersection update, symmetric difference update. These methods computes their function in the same manner, but replaces the set on which the method is called upon with the answer that it computes. Let me show you an example of just one of these. So let's have the intersection update method. I call the method on A and pass in B. This returns nothing, but it replaces the elements of set A with the intersection computed, just like in place methods. So now if I print set A and if I run it, we can see that set A contains the result of the intersection of both A and B. There is also a shortcut to use all the methods we just specified. Let me grab few one of them from my snippet. So instead of A dot intersection B, you can use A ampersand B. This will produce the same output. But notice that this shortcut works only when both A and B are sets. But if we use its full form A dot intersection B, we can pass in either a tuple or a list in its arguments. So if we have a list, you have to convert it into a set before using the shortcut way. If we have multiple sets, we can use A ampersand B ampersand C and so on. Let me show you a practical application of sets. Let me grab my snippet. Let's have two lists as magazine names, crimes and technology. The list contains the name of the people that are subscribed to the magazine. We can see Jane, Sherlock, Light and L are subscribed to Crimes magazine. And Rick, Cisco, Jane and L subscribe to Tech magazine. So if I want the names who are subscribed to both Crimes and Tech, we use the intersection method. Since we have them as list, we need to convert them to a set in order to use the set methods. If I print it, we get the result as Jane and L. If I want just the list of all the peoples who have subscribed to any magazines, we use the union method. And this just prints the list of all the names one time.